All right, here we go. Another lesson where you're going to need your calculator because we are going to work with combinations now. So combinations, your locker combination is a lie. Why is your locker combination a lie? You'll find out in just a minute. So we have 6 paintings that are entered into an art contest. How many different ways can the paintings finish first, second, and third? Well, we have first place, second place, and third place. So the order in which they finish matters. So this is a review from permutations from the last video. We have 6 possibilities, and we want to figure out how 3 of them can finish in first, second, and third place. Remember, that's where you use your calculator, and you get 120 different ways. So combination. Combination is a selection of objects from a group where order does not matter. So, if you have 3 numbers on your locker combination and you just went up and put them in any order, it wouldn't work. It does have to be in a specific order. So your locker combination is actually a permutation because it must be done in one correct order. So, we have 3 paintings that are going to be chosen to display at a gallery from a pool of 6 different paintings. How many combinations of the 3 can be chosen to display? So this is a little bit different. This one doesn't have a first place, a second place, and a third place. This one just has, let's pick 3 paintings and hang them up. So this is what you would call a 6 choose 3 instead of 6 permutate 3. So your calculator has this feature as well. So we're just going to go to 6. Remember, math and slide to probability. This time we use number 3, NCR. So we've got 6 to choose from. I'm going to choose 3 in no particular order, and I have 20 different possibilities. Okay, now notice it's the same thing. When order does matter, we have 120. But if order doesn't matter, it doesn't matter if a painting finishes first, second, or third place. It doesn't matter. We're going to hang up 3 paintings in no order. Then there's a lot less different possibilities. All right? So when we're playing with a deck of cards, so you have obviously 4 suits. 2 of them are red, 2 are black, and each suit has 13 cards, an ace, 3 face cards, and then the rest are numbers. If the order is not important, how many different 7-card hands are possible? Okay, so this is an example where if we were to be dealt 7 cards, it doesn't matter if you get the ace of spades as your first card or as your last card, you still have that card in your hand. So the order is not going to matter how you get it. But it's still going to be pretty big because you have 52 cards to choose from, and you're only going to choose 7. So calculator will tell you 52. Math, slide to probability number 3. I want to choose 7 of them. Yep, that's a pretty big number. You have 133,784,560 different possibilities for a 7-card hand. Pretty big, don't you think? So, B, how many of these hands have all 7 cards of the same suit? Okay, so this one is a little bit trickier because you have to remember this is the same suit. So, if you're not familiar with a deck of cards, at the top it says each suit has 13 cards. So this is 13, choose 7. And that's going to tell you how many for one suit. So 13, choose 7. Is going to tell you that you have 1,716 possibilities, but that's per suit. So you have spades, clubs, hearts, and diamonds. So you have to multiply that by 4. There's actually 6,864 different suits, or what we know as a flush hand that you can get with 7 cards. So that's a little bit trickier to get. I mean, there's over 133 million hand combinations for 7 cards, but there's only 6,864 out of those 133 million of getting a 7-card flush. As you see, it's pretty rare. To add, subtract, or multiply? That is the question. So what are you going to do here? So you want to visit 3 cities and 4 attractions if we're going to take a vacation where we can visit as many as 5 cities and 7 attractions. So this is going to be a multiplication problem because we have, we're just going to mix it up. So we want to see 3 out of 5 cities, so that's 5. Choose 3, but we also want to have 4 of 7 different attractions. So we have 7 attractions to choose from, and we're going to choose 4. Now, because we can mix and match this any way we want, we're just going to do 5 choose 3, which is going to give you 10 with your calculator, and then 7 choose 4 is going to give you 35 with the calculator, and all you have to do is multiply those together, and you will see that you have 350 different kinds of trips that you can take. All right? But then suppose you want to visit at least 8 locations, city or attractions. How many types of trips are possible? So this is a little bit different because it says that you want to see at least 8 locations, period. It doesn't matter if it's a city or an attraction. So this is where things get a little bit tricky because you have to remember that it says at least. So if you wanted to do the minimum trip, then you have 12 possibilities of cities and attractions combined. And remember, there's 5 cities and 7 attractions, so that's 12 different, let's call them sightseeing opportunities. And you can choose 8. Or, since it says at least, you could also choose 9. Or maybe if you wanted to stay a little bit longer or had a little bit of extra money, you can choose 10. Or maybe you wanted to go see 11 out of the 12 attractions. You just found one that was closed. Or you just wanted to go all out and you wanted to see all 12 attractions on your vacation. You can see this many different possibilities. So, again, this is just using your calculator. There's 12 options. If you choose 8, you have 495 different options of a vacation. If you wanted to choose 9, you have 220 different possibilities for a vacation. And then if you only wanted to choose 10, then you would have 66. If you chose 11, you have 12 different possibilities. And then if you had 12, you only have 1 possible vacation because you're going to go see everything. Okay? But if you wanted to say see all but 1, then you have 12 different possibilities because you have 1 attraction you're going to eliminate from all of those different possibilities. And then you would add these all together and you have 794 different types of trips that you can take because it says at least. All right? So, last problem. We're going to create a salad. Now here's the thing about a salad. Does it matter if you put the lettuce and then the tomatoes, or if you put the lettuce and then your mushrooms, or if you want to put lettuce and then bacon and then put on tomatoes? The order which you put the ingredients in a bowl does not matter because you're just going to shake them up, mix them all together, and then you're good to go. So, how many different salads can be made if you have bacon, tomatoes, croutons, cheese, mushrooms, and chicken? You have 6 different possibilities. Now, remember, if you don't like mushrooms, you don't have to have mushrooms on your salad. So, this goes back to the vacation from above. We can say we want 6, choose 0. What if you don't like any of those toppings and all you want is a bowl of lettuce with a little bit of dressing maybe? And then, let's say that you have 6 toppings to choose from, but you're going to choose only 1. Let's just say the only thing you want is bacon because bacon makes everything better. So you can have some bacon on your salad. And then, of course, you see where I'm going here. You can choose 2. You can choose 3. All the way on up until you get to 6, choose 6. And then you would find every single one of those. And it would start with 1, 6, 15, 20, back down to 15, 6, and 1. Add those all together, and you would end up with 64 different possibilities for a salad if you choose 0, 1, 2, 3, 4, 5, or all 6 ingredients. Okay? Because again, order does not matter here. If you had to put the bacon before the tomatoes, well, then that would be a permutation, but it's not going to make a difference in the taste of the salad. So, on a deluxe salad, you have up to 4 toppings. How many different combinations can you have? Well, this says up to 4. So that means you can just do 6 choose 4 plus 6 choose 3 plus 6 choose 2, 6 choose 1, and 6 choose 0. Now, I don't know why you would order a deluxe salad if you weren't going to pick anything, but this particular place says up to 4 toppings. So this is just slightly different than the one before, because the one before you can go all the way up to all 6 if you want. This limits you to 4. So that's going to bring you to 15 plus 20 plus 15 plus 6 plus 1. And that's going to give you 57 different possibilities. All right? So that's combinations for you. This is when order does not matter. So you have permutations. Order does matter. Horses racing, finishing in first, second, or third place. But art, we're going to pick any random 3 pictures and hang them up on the wall. That's choosing because the order does not matter. All right? This is Longo, and I'm out. See you, bye.